Hello, good morning everyone. So in today's session, we'll be discussing first normal form and second normal form. In the last session, we had a discussion related to the process of normalization. So I hope you must have understood this process. So let me quickly summarize the process of normalization once again. So what we have here is, see, we begin with data collection. So if we want to build any database application, then the first step is gathering the data, right? So there are various sources for collecting the data. So we collect the data and we come up with the requirement specification. So basically, while building the database application, after this process of gathering the data, we come up with all the required attributes. Those we would like to store in our database. So what we do is, we transfer all those attributes into a tabular form. And we say that it is unnormalized form, UNF, unnormalized form. So all the attributes, those are required to store the data, those are actually dumped into a single table, and this table is the unnormalized form of database. Now, normalization is actually a formal technique for analyzing relations based on the candidate keys and the functional dependencies. So as I stated earlier, this technique involves the series of rules. Those can be used to test the individual relations so that we can come up with a normalized database of certain level. So actually, what we do is we go on imposing certain rules. So every normal form is having certain properties, or every normal form needs to impose certain rules on the database. And the relations, those are not satisfying the rules, those relations are being decomposed. And we come up with the decomposed relations, those actually follow the rules, those are defined in that particular normal form. Typically, there are three basic normal forms, those were proposed initially. And these three normal forms are listed over here: first normal form, second normal form, and third normal form. So as I stated, whenever we collect the data, initially we come up with the unnormalized form of database. So it may happen that in this unnormalized form of database, we are having certain data that is grouped together. So some of the attributes are having the groups, right? So if we try to remove these repeating groups, then we come up with the first normal form. Now, once the table is in first normal form, that there are several partial dependencies in those relations. So the next step is we remove the partial dependencies, and after removing the partial dependencies, we come up with the second normal form, which is known as 2NF. Now, whenever we are having the database in 2NF or the relations in 2NF, it may happen these relations are still having some transitive dependencies. So we try to remove this transitive dependency. We were talking about the process of normalization. So we are having three basic normal forms: first normal form, second normal form, and third normal form. So as we proceed with these normal forms are actually imposing more and more stringent rules on our database. So in fact, while we are following this process of normalization, so if you remember, we have found out or we have defined the goal for normalization earlier. And the most important aim for normalized database is to avoid redundancy in the data, because the redundancies are actually causing the anomalies, right? And we have seen three kinds of anomalies. If you remember, we are having insertion anomalies, deletion anomalies, or updation anomalies, right? And we don't want to have such anomalies in our database, and that is the reason why we are following these steps of normalization. So as I stated, as we move on, right, we are trying to reduce the anomalies in the database, and we come up with a good database. So if I am having one NF, that is not enough, so I may proceed with 2NF. So if I am having the database in 2NF, still I am having some transitive dependencies, and those may result in updation anomalies. So once again, I need to remove those anomalies, or I need to remove those transitive dependencies from 2NF, and that is why I may go for third normal form, that is 3NF. So ultimately, this 3NF is that whenever we design our database, at least our database should conform to this 3NF, right? Further, more stringent form of 3NF was introduced. Two higher normal forms were introduced, and those were the fourth normal form . So first normal form, the second normal form, third normal form, and the Boycott normal form, they are based on the concept of functional dependency. Further, these higher normal forms, 4NF, 5NF, those are actually, 4NF is based on multi-valued dependencies. That concept we are going to discuss later. And the fifth normal form is based on the concept of joint dependencies, right? So please remember, this second normal form, third normal form, B7, and the fourth normal form partially are dependent upon these functional dependencies, right? So we are going to have a detailed discussion about all those normal forms. Okay? Let's summarize the things those we have discussed so far. Initially, our data is in we call this database as UNF, right? So a table contains one or more repeating groups in unnormalized form. So the normalization begins with this unnormalized form. So this normalization process is actually the bottom-up process, right? So what we do is, initially we extract the information about the attributes from various data sources and we transform this data into a form of a table, and we say that it is in unnormalized form. Further, this table in unnormalized form is subjected to the different requirements associated with various normal forms. And with respect to every normal form, if we comply with the requirements of that particular normal form, then we come up with the set of relations under that particular normal, and we go on having the higher and higher normal forms so that we can build a data system redundancy and not having any anomalies, right? That is our goal for building a good database. Now, let us begin with this first normal form. We know that every attribute is associated with a domain, and we say that domain is atomic if its elements are considered to be indivisible units. So what is the atomic domain? If the elements cannot be decomposed into the parts, then we say that it is atomic domain. So examples of non-atomic domains are set of names or the composite attributes. These are the examples of non-atomic domains, right? So we know the concept of atomic domains now. This concept, or 1NF, is based on this concept. A relational schema R is in first normal form if the domains of all attributes of R are atomic. What does this mean? If I am having a relation, right, then what I want is every attribute should be associated with the atomic domain. We do not prefer to use non-atomic domains. And if a relational schema is in first normal form, then we are having all the attributes with atomic domain. In other words, we may say that a relation in which the intersection of each row and column contains one and only one value, then we say that the relation is in first normal form. So when designing the database, this is a basic requirement that all our relations must be in first normal form, meaning all the attributes in the relations should be atomic. Let us see the example of non-atomic values. In fact, the non-atomic values complicate the storage. And these non-atomic values actually encourage redundancy while storing the data. Say for example, if we talk about our university schema or in university database, right? In our university database, we are having students, and students are opting for several courses. Right? Now, if I store this information, like I am having student ID, that is one attribute or one column in my table, and the courses opted by the student, And if I store the data, say like student ID, say 1001, and this student ID 101 or this student 101 has opted for say 3 courses. And if I store all those 3 courses in the form of a set under single attribute courses. Say for example, I'll be storing like CS 101, CS 123, and suppose CS 132. These are the 3 courses which follow this strategy to store the data. Then how I am storing this data? I am having a separate column to store student ID, and I am having one column wherein I will be storing all 3 courses together in the form of a set. Right? So the domain for these courses is non-atomic. Why? Because I am having this set of values under this attribute. And if I am having set of values in single column, then this is a non-atomic way of storing the data. So this particular attribute courses is non-atomic, right? And we do not want to have such kind of a design. Okay? Similarly, if I want to store the set of students who have opted for a particular course, then if I choose to have a table wherein I am having a column say course ID and I am having another column say students, and how I am storing, say for example CS 101, and here I will be listing out all the student IDs who have opted for this course. Right? So once again, this particular attribute student is non-atomic. Why? Because in the same column, for the same row, I am storing set of values. Right? So this is not advisable. Okay? So if I go for such kind of a design or such kind of a design, then these relations are not in one another. Okay? Why? Because we have another condition also. What this condition says? A relation in which the intersection of each row and column contains one and only one value. Then it is in one or first normal form. So if we consider this column and this row, right? So intersection is this cell for this column and this row. And in this cell, I am having more than one value. So this is not in one another. If I am having an intersection of row and column, if I am having only one value, then I'll say that it is in one another. Right? And in one another, a relational schema R in first normal form if the domains of all attributes of R are atomic. Or in other words, we say that a relation schema R is in first normal form if the relation or the intersection of row and column of the relation contains one value. We say that relation is in first normal form, and by designing a database, the very basic requirement is our relations should be in one another. So let us give an example and the approaches. If we are not having the relation in one another, then how to convert the unnormalized table into one another. So whenever we want to have a relation in one NF, we need to remove the repeating groups, right? So we are having approaches for one NF. What is the first approach? By entering appropriate data in the empty columns of rows containing the repeating data. So this approach is commonly referred as flattening of the table. Flattening the table, right? So this is approach number one, to convert a normalized table into one NF. And the second approach is by placing the repeating data along with a copy of original key attribute in a separate relation. So we are going to discuss both these approaches. How to convert the unnormalized table into one NF by following these approaches. So let us see one example. Suppose we are having the property cards. So there are few properties and those properties are being rented to certain clients. Okay, and for every property there is a property card, lease card like this. So what we have on this card, we are having several attributes for which the information need to be stored. Okay, so on this property card we are having client number, name of the client, property number, address of the property, monthly rent, starting date, ending date for the rental period, owner number and owner name. Okay, so these are actually the attributes those we would like to store. Let us assume that a client rents a given property only once and cannot rent more than one properties at any one time. So this is the assumption that we have. What is the assumption? Client rents a given property only once and cannot rent more than one properties at any one time. Right? Now, if we are having this data, the very first step is we should dump all those attributes in a single table and we should come up with the unnormalized form of database, right? So, by dumping all the attributes in the single table, we come up with such kind of a relation or a table, wherein we are having all those attributes. We are having client number, client name, property number, property address, rent start, rent finish, rent, owner number and owner name. So all the we are having in this relation. Now, see whatever we have right now on our screen, we are having a client rental table wherein we have stored all the attributes those we want to store or for which we want to store information. So my question is whether this table is in one NF. If yes, why? If no, why? So what is the definition for one NF? Everything is available on screen now. What is the definition for first normal form?
If relational schema R is in first normal form, if the domains of all attributes of R are atomic.
So what does this mean? What we mean by atomic domain?
If elements are considered to be individual units, then it is domain, atomic.
Okay. So in other words, if we want to define 1NF, how we are going to define it?
For which we have to consider each element to be the individual unit.
So meaning, see here on this slide, if I am having these two tables, whether these tables are in 1NF, in one table I am having student ID and in another column I am storing the courses. So whether this table is in 1NF, whether
Yes.
this attribute courses is having atomic domain. Yes, anybody? Whether this particular column courses in this table, whether this column or whether this attribute is having atomic domain. What is my question? Whether this attribute courses in this table has the domain which is atomic or the domain is non-atomic.
Non-atomic,
What is the reason?
because it having the multiple values.
If in a particular relation, if the intersection of a particular row and column contains more than one values, then we say that it is not in 1NF. If the intersection of each row and column contains one and only one value, then we say that it is in 1NF. So these two relations are not in 1NF.
No, ma'am, not in 1F form.
This relation is not in 1NF. And what is the reason?
Because property number or there are some attribute having the multiple values.
Yes. So we are having several attributes wherein we are storing the set of values. So say for example, in property number, we are having two values stored. In property address, we are having two values stored for this first row. So that is the reason the intersection of this row and this particular column. Say for example, the intersection of this row and this particular column contains more than one value. Intersection of this row and this column also contains more than one value. The reason these attributes are having non-atomic domains. And that is why this particular relation is not in first normal form. So, if we want to convert this relation which is in unnormalized form into 1NF, we are having two approaches. Right? Or the relation. So how we are going to flatten out this relation? Simply see here in this particular row number 1, we are having two values for these attributes. So why not to treat these two as separate rows? So are you getting me? We have identified that there are several attributes, right? So to convert this unnormalized table in first normal form, we are having the first approach, and that is flattening the table. So simply what we are going to do is, here we are going to treat these two separate rows. And if we are going to treat these as two separate rows, simply we are going to repeat here this client number and this client name. And this one row is now being converted into two different rows. And now if we look at the table that is flattened out, right, we may find that every row now or intersection of every row and every column contains a single value, right? So now we may say that this table is in first normal form, right? So original table is being converted now into first normal form, and the approach that we are using here is flattening the table. Meaning, if we are having repeating groups in a particular attribute, then for every single value, right, we are going to consider a separate row. Right? So whichever are the columns, those become empty. If we convert it into the row, so whichever columns become empty, we are going to replicate the respective attribute values in those rows, right? And we are going to come up with a table which is in 1NF. Are you getting me?
Yes,
Yes.
ma'am.
So I hope you must have understood this first approach, flattening the table. Okay. Now, the second approach I'm going to discuss, but before that, let us look at this table now, which is in 1NF. And if we try to find out the functional dependencies in this table, we may come up with several functional dependencies. Like client number, property number determines rent start, rent finish. Client number determines client name. Property number determines property address. Owner number, owner name. Owner number determines owner name. Further, client number, rent start determines all other values. Similarly, property number, rent start determines client number, client name, rent finish. So these are the several functional dependencies. Those we may come up with. Okay, so this table is in 1NF, and for this table we have identified few functional dependencies. If we look at those dependencies, we may find that few of the dependencies are partial dependencies. Few of the dependencies are transitive dependencies, right? So as I stated, 1NF is the basic normal form that we should have. But if my table is in 1NF and if I am having partial dependency, then I need to remove those partial dependencies and I may come up with a second normal form. If my second normal form is having transitive dependencies, I need to remove those and I may come up with a third normal form and so on. Right? So once we have created a table in one NF, we need to think of the functional dependencies that we have so that we can proceed with higher normal forms. Right? Now, the second approach to convert the UNF, that is the unnormalized relation, into first normal form is by making use of separate tables. So once again, what we are going to do here is, given a single table, what we are going to do is, we are going to place the repeating data in a separate relation along with the copy of the original key attribute. What does this mean? See here, we are having this table in UNF, that is the unnormalized form, and we would like to convert this table in one NF. So, which are the repeating groups? Property number, property address, rent start, rent finish, rent, owner number, owner name. These are the repeating groups. So what we are going to do is, we are going to decompose this relation into two relations. And in one relation, we'll be placing all those repeating data, all those attributes for which we are having repeating data. Also, we are going to add the key attribute into that relation. So, we will be having these two separate tables now. So, what we are having here, these were the attributes for which we were having repeating data. So, what we have done is, all those attributes are kept in one relation. The key, client number is the key. So we have added this client number to identify which property belongs to which client, right? And we have come up with this separate relation. And another relation that we have is client number, client name. So now these two relations are in one NF. This is also in one NF, this is also in one NF. Is that clear? Yes, is that clear? So in this approach, we have created two separate relations. So whichever are the attributes, those are having repeated data. These attributes are separated and we are forming a new relation out of that. But along with those attributes, we are adding the original key attributes. So here client number, right? And we have come up with this table. Also, we are having the other table with the key attribute client and the remaining attribute, that is CNAME, client name. So now we are having these two separate tables. Both of these tables are in one NF. Do you agree with me? Yes?
Yes, ma'am.
Yes?
Yes.
Yes, ma'am.
So I'm simply introducing second normal form and then we'll conclude. So now, if we are having the relations in one NF, still we may find that there are several partial dependencies. Right? And if we are having the partial dependencies, we need to remove those partial dependencies and we may come up with the second normal form. This second normal form is based on the concept of full and partial functional dependencies. So second normal form applies to the relations having the composite keys, meaning the relations with a primary key which is composed of two or more attributes. So if the relation is having the primary key comprising of two or more attributes, the second normal form applies to such relations. Okay? Now, a relation with a single attribute primary key is automatically in at least 2NF. But if the relation which is not in 2NF, as I stated, that relation may suffer from anomaly. And that is why we need to come up with the second normal form. So let us see the definition of second normal form and then we'll conclude. A relation is in second normal form if and only if it is in 1NF. It is in first normal form. And every non-primary key attribute is fully dependent every non-primary key attribute is fully dependent on the primary key. If the relation satisfies these two conditions, then we say that the relation is in second normal form. And if all the relations of the database are in 2NF, the entire database schema is said to be in 2NF. So please note down this definition. Please note down this definition of 2NF. We are going to discuss few examples of 2NF in the next class. And also we are going to see how the relation which is not in 2NF can be converted into 2NF. Right? So I hope you must have understood these concepts. Okay, so in today's session we have seen first normal form and the definition of second normal form. In the first normal form we have seen the definition, we have seen the example, we have seen the approaches how to convert the unnormalized database relation into 1NF, and we have seen the definition for second normal form. In the next class, we are going to discuss the applications or the examples of second normal form and how to convert the relation in second normal form. So let's stop today. Thank you.